Good morning or good afternoon, depending on when you see your science class. We are talking about a very short little section today called Cnidaria. Cnidaria has a silent C in front of it, so just get rid of that C and pronounce the word Cnidaria. Actually, there's a little hint here. If you turn that C 90 degrees, it kind of looks like the top of this jellyfish. Okay, so you can take the C and kind of imagine some tentacles coming out of the bottom right here, and it kind of looks like a jellyfish. So maybe that'll help you out. So Cnidarians. So these guys have stinging cells. That's actually what the word Cnidaria means. They have radial symmetry, so remember that means just like a pizza. You can cut them in half a couple different ways. For jellyfish, it's going to be typically 4 ways. Starfish, it's going to be 5 ways, but a starfish is not a Cnidaria. That was just another example of radial symmetry. So radial symmetry. They take food into a central body cavity. This means is a basic stomach. So if you've ever seen a jellyfish, they obviously have tentacles, and you're not supposed to get stung by them. Okay. So the tentacles will grab a fish, it'll sting it to death, and then it'll curl the tentacles up into the dome that is the rest of their body. And in there is a central body cavity. It's kind of like your stomach, okay? Except you don't reach your arms all the way down into your stomach. So the fish will get dissolved, it will start to break down, and then eventually the fish's skeleton will get pooped back out. They do have tissues made up of cells. So unlike porifera, these guys do have some tissue. So what you're seeing here is you're seeing a jellyfish before it actually turns into a jellyfish. So this is a baby jellyfish, kind of. Okay, so you can see the different colors here represent different things. It probably has some muscle, gastrovascular. What that means is that's the stomach, so it has to have special cells in order to withstand the chemicals, just like your stomach has chemicals in it. I think we've talked about before, if you ever burp and a little bit of like fluid comes up and it kind of burns your mouth and your esophagus, your throat, those are the chemicals coming up out of your stomach. So same thing here, this stomach has chemicals in it that's going to break down the fish or whatever it's eating. These guys do have a nerve net. So we've talked about in the symmetry note how you can't sneak up on a starfish. Same thing here with a jellyfish. You can't sneak up on a jellyfish because it allows, this nerve net allows it to sense all of its surroundings. So you can't walk up on a jellyfish, well, swim up, of course, and scare him because it has eyes, air quotes, eyes all the way around its body. You can see here all these little blue spider webs. All of those are nerves. You have nerves all over your bodies too, except they look like spaghetti, not like a spider web. So your nerves are just one long string rather than a spider web like this guy has. Excuse me. So we're almost already done. So your example organisms are going to be a jellyfish, a sea anemone, coral, and something called a hydra. So the pictures are coming in correspondence. So you have a jellyfish, you have a sea anemone. Corals, actually, a lot of them do sting you. So if you've ever been scuba diving or snorkeling, they're going to tell you not to step or touch on the coral for 2 reasons. One is you're going to break it, but 2, a lot of times they might sting you. So that's obviously not good. And then hydra right here, these guys are really cool. They have stinging cells all over them, and they're real tiny, and you can see they live down in the dark. So they're pretty cool, but most likely you haven't seen them before. And that's it. I mean, you're done your notes for the day, so go back to Google Classroom or look at the front whiteboard to figure out what you need to do next.